Hey everyone, it's Aiden from Team 7121E with another Fusion 360 tutorial. I'm going to be demonstrating some very basic construction techniques, kind of the fundamental core things you need to know to start building robots in Fusion 360 in terms of joining and creating rigid structures. So I'm going to go off and just create a very basic chassis. So I'm going to use this part library that I made in the last tutorial video. If you haven't seen that yet, I recommend you watch that first because that tells you how to get all of these parts in the first place. But we're going to be focusing primarily on just one part for the majority of this video, and that is C channels. So I got two files here. I have the wholly 3 wide and the wholly 2 wide. Now, I'm not going to get into topics of build quality, but we're going to make this chassis out of 2 wide C channels. And we're going to make a very simple, if I have already made a mistake here, we're going to make a very simple 30 by 32 chassis. So first we're just going to save real quick, because you can't drag and drop anything until you save and name a project. So we're going to name this something simple, early season chassis. So now that we got a project here called early season chassis, we're just going to drag and drop a couple C channels here. We are going to angle them in the way we want them to. So this is a demonstration on how to rotate and manipulate the angular geometry of your C channel. So you can rotate them on the X, Y, and Z axis. So here we're rotating on the X and the Z, or no, this is, yeah, we'll call this Z. It's kind of hard to determine in a three-dimensional. Oh no, actually it's telling me right here it's the X angle. Awesome. Alright, so I'm royally failing at this tutorial already, but that's irrelevant. We're just going to eyeball what angle we need this to be at. And we're going to flip this around for simplicity's sake. Alright, perfect. So as you can see, we got a C channel, and we're going to copy and paste it just so we have two of them. You don't necessarily have to copy and paste, you can just drag and drop on every C channel in, but we're just going to copy and paste because why not? So now you got two C channels. So these are going to be the C channels that go along the width of the robot. However, how do we cut these C channels? Because as you see here, they're 35 holes long, but we need this to be 30 holes long. Well, the way we do that is by using midplanes. So what you're going to want to do is you're going to want to go to construct, and you're going to want to find the midplane option. And you're going to be put up to this screen. So the way that you create a midplane is by selecting any two planes, so any two flat surfaces, and it will create a construction plane of sorts in your project. Basically what I'm saying is, if you want to cut a C channel to a particular hole, you're going to want to find one of the middle holes of the C channel, and you're going to want to create midplanes between the two holes. So in this case, we want to create this 35 long into a 30 long. So we're going to want to chop off these 5 holes. So we're going to go to this middle hole, and we're going to select this plane. We're going to angle it, and we are going to select this plane. And it'll create a midplane in between these two planes, hence the term midplane. And we're going to click OK. So as you see here, it has created a sort of imaginary cut that goes in between the little nook in the C channel. So now that we created this midplane, we're going to go to modify, and we're going to go to split body. We're going to split the part that we want to cut, which in this case is the C channel. So the body to split is this, and I have made an oopsies because I did not unlink the C channel. Hold on. You're going to want to break the links on both of these C channels before you actually do anything with them where you can't modify them. So we're going to split the bodies, we're going to select the C channels, and the splitting tool in this case will be the midplane. And now we're going to click OK. Now notice here we have this line going through the C channel where our midplane is. we have created two separate bodies. We have created body 1, which is this body, the 5 holes that we wanted to cut off, and body 2. Now, we know that we want to get rid of body 1 because those are the 5 holes that we need to get rid of to get 30 wide. So what we're going to do here is we're going to right click on body 1, and we are not going to click delete. Clicking delete creates some awkward issues that are easily avoided if you just click remove. Alright, and then once you click remove, you're free to delete the midplane. But only delete the midplane after your move, not before, or else you're going to have to redo everything again. And we're going to do the same thing here. We're going to create a midplane by going to the middle hole of whatever we need cut. So we're going to cut off these 5 holes. Okay. We're going to split body. Splitting tool. Okay. And we are going to go back here. See that we need to get rid of body 2. Right click, remove, and then delete the midplane. Now you see we now have these little ugly floating dots and planes. These have no reason to be here. Obviously we're not going to join anything to anything here, because if this was a real robot, this would just be empty space. So at this point, you're free to use the selection tool, which is your left mouse button. Just drag over these excess planes, and you should theoretically be able to, there we go, I don't know why I wasn't doing it there. So you could just hover over those, select all of those, and delete. Just use the delete key on your keyboard. And you'll still have these little dots. There's not really anything you can do about these. These are always going to stay. But it does clean up things a little bit. And if you use an app like A360 to view your CADs, none of this shows up. It'll just show the solid bodies, none of the iMates or the construction planes. So now that we have these 2 C channels, we need to give them, say, longitudinal, lengthwise C channels to accompany them. So we're just going to spawn in 4 C channels, and we're going to orient them to how we want them. Usually if you want to save time, instead of just, going here and dragging it to 90 degrees, you can just go here, edit it a little bit, and then just type in 90, and it instantly snaps to it. So we're going to create just 4 C channels. Really doesn't matter where they are now. We're just going to plop them into randomness, and we're going to make them all coherently attach in just a minute. Okay. So we have all of our C channels, and we don't necessarily need to break the links on these, but we're just going to go and break all of the links here. Just so, actually we are going to have to break the links later because we are going to cut these. We're going to cut 3 holes off of them. Okay. So we're just going to move this out of the way so it's a little bit easier to see what we're doing. And we are now going to joint the C channels together to create a rigid structure. So to do this, notice how on all of the C channels we have these little white dots. What we're going to do here is we're going to select one of these white dots. Well, first we're going to click joint and click continue. Not sure what happened there. What? Capture position. Sorry, you want to click capture position. And you're going to want to select these dots. So you're going to want to select the dot here, and you want to select it to the accompanying dot that you want to mount it to. So in this case, we're going to mount it to this dot. It's not arbitrary where we're mounting it. This is just so if this is how you want your structure to look, you're going to match it to how you would want it to look in real life. And then we're going to click OK. And we're going to repeat that. We're going to make this, say, a 4-hole wide gap, wheel gap. Select that. 1, 2, 3, 4, and then just pop it here. And we're going to repeat that with the other two C channels. So this is basically the fundamental idea of how you connect C channels together with the holy C channels. You just use the eye mating dots, and you connect and joint the dots to whatever dot you want it to join to. It is 2:50 a.m., so I apologize if I'm kind of incoherent here, but I'm hopefully the visual representation of what I'm doing is slightly better than my verbal explanations. And here we go. So now all of our C channels are linked. And we have here this other C channel. This is because, of course, when you're making a chassis, you're going to want at least 2 C channels going across the entire robot. Of course, when you're making a real robot, you might think a little bit more carefully as to where you put the C channel, but we're just going to throw it really anywhere. It doesn't really matter. And an important thing to note, you don't need to join every C channel. So like basically once you create a joint here on this C channel, you don't need to create 2 more joints here and here to link this C channel to this C channel and vice versa. Once it's connected to this, it's connected to this entire structure. To emphasize this, alright, let's see how this works. If I move this C channel, for example, it'll move the entire chassis structure, because this C channel is jointed to this C channel, which is then jointed to this C channel, which is jointed to this C channel. Okay, so it's all transitive property. So it all connects to each other. It's all uniform. But as we said, we wanted to make this 30 wide, which we've already done, and 32 long. Now I'm going to show you something that you can do in this scenario. We have 4 C channels. All of them are on the same plane, and all of them are pretty equal in how they're laid out. So what this allows us to do is, instead of creating 4 midplanes for 4 C channels, we're just going to create 1 midplane for 4 C channels. So we're going to go to any one of these C channels. This one is looking the cutest, so I'm going to cut this one. And we're going to cut these 3 holes off. So that means we're going to cut 1, 2, 3, this one, yes. We're going to create a midplane like we did before. Select OK, make sure that this is correct. Yep, so we're cutting off 3 holes. And this midplane, even though it only shows it to be this square, in reality, according to the program, this goes on for infinity in every direction. So what this allows us to do is allows us to go to split body, and we can select all 4 of these C channels and select this one splitting tool. And if we click OK, it will split all 4 of these C channels, because this midplane intersects the exact same points on all of these C channels to these C channels, so it creates a nice clean cut all the way across the robot. So we're going to do what we did again here. We're going to go to bodies, and we're going to remove what we don't need. Go to bodies, remove what we don't need, and go to bodies and continue doing that until we get what we intended to make. Alright, so like that, we've removed all the bodies. That sounds pretty morbid, but we've removed the bodies, which means we can now delete the midplane. And now that we have all this little excess crap, we can just select it. Let's go in this view because maybe it'll be a little bit more friendly. There we go, and then just click delete. And you're gonna get like weird split warnings. For the most part, just pay attention to these to make sure you're not doing anything stupid, but you can kind of ignore these because they're not really gonna affect how your construction looks. So just like that, we've created a 30 wide by 32 long chassis. which is pretty great. But obviously, a robot is more of a chassis. So we're going to have to add things like wheels and bearing flats. There are two ways that you can model wheels and like sprockets and whatever, your wheelbase. You can either do it the proper way or the improper way. I'm going to show the proper way first, and this involves me tapping into another project, so let's hope I don't accidentally, well, this is from last year, so I'm not going to leak anything, but we're going to go into here and we're going to spawn in a bearing flat, and we are going to just orient it to exactly how we need it. And we are going, actually, I did this wrong. I need this to be the other direction. Realize how these C channels are laid out. It's not like how it is on my actual robot. And then from here we could just copy and paste. Capture position. You always want to capture the position. If you just press continue, it creates a lot of weird problems that you can just easily avoid by saying capture position. We're going to spawn in a drive shaft, and this we're just going to keep at this angle. We're going to spawn in a sprocket and angle it to how we need it. I accidentally made that perfect, but that was by accident, but that's kind of foreshadowing what we're about to do. And we're going to go and throw in some wheels as well, so let's put in some 3 1/4 inch traction wheels. This one. Oh yeah, this one we're gonna use spawn. Okay, so we have all of our components for a wheelbase. So this is the proper way to do it. It's, you know, in air quotes, proper ways. It's a little bit time consuming, but if you really want to make things a little bit more professional looking, then this is sort of the way to do it. And even then I'm kind of cheesing it because I haven't really practiced enough with this to say that it's the proper way, but this way you create a lot more joints and you make this entire thing rigid. There's a quicker cheat way that I prefer to do it, but it kind of just involves making the wheels and sprockets float in existence and not connect them to anything. But let's just continue. So these bearing flats do not have eye mating points, but just because they don't have eye mating points doesn't mean we can't joint them to the chassis. If you notice, when you press joint, you can select these planes and it'll create a joint point for you, right? So the way we'll do this for our chassis and connecting the bearing flat to our chassis is if you go to these holes here, it will actually create a joint point, location, what does it say? For a component to move. All right, that's a good description. At the circumcenter of, say, this little cylinder part here. So we're going to select that. So that's component 1. And we are going to link that wherever you want that bearing flat to be. In this case, we're just going to put it right here. And here's something important to note. The eye mating points on VC channels are only accurate to the flat sides of the C channels. So that means if you try to join anything on here on the inside of the C channel, it's not going to be aligned right. So notice here, Fusion doesn't want to freeze on me, that this isn't aligned correctly. Obviously these little knobs, these little clip-on points should be snug within the little gap here in the C channel. And this will be the case always. So it'll always be offset by exactly 1.5 millimeters. So that is a golden number that you're going to want to remember in your head. Anything that you joint to the inside of C channels, you need to offset the joint by 1.5 millimeters for it to be aligned, because this is 1.5 millimeters in width. All right. So we're going to repeat that on the other side. Assemble another joint. And just connect it here. Same deal. I remember this was on the z-axis, so we're going to do 1.5 and negative 1.5 actually. Okay. And now we have rigidly mounted these bearing flats. So if we move anything here, it's going to keep the bearing flats in line. Now, we want to put the axle here. So how do we put the axle into the bearing flat? How do we join the axle to the bearing flat? Well, it's also important to note that an axle is a revolving object. So there are multiple types of joints. We've only shown rigid joints here because when you're making a chassis, obviously it's a rigid structure. But you can make, I'm going to butcher the word, revolute joints. You can make slider joints, cylindrical joints. Really, the only ones you're going to use are rigid and revolute. So we're going to select a revolute type joint, and we are going to select this little circular bit at the end of the axle. And remember how we can create a joint from the circular bit inside the bearing flat here at the circumcenter at the end of this cylindrical tube here. So we're just going to select that as well, and it'll create a joint. As you can see, it's trying to calibrate the movement, so it's going to rotate a few times inside of there, and we're going to click OK. Now what's awesome about revolute joints is that once you create them, it'll create this little flag here. You can double click that flag, and then you could freely rotate the object on that joint's axis, on its axis of rotation. So we're just going to leave that at 0. This is really good if you have a lift mechanism, you want to model a lift mechanism, you'll put the joints as revolute so that when you move one side of like a 4-bar, it'll move just like a 4-bar would in real life. You wouldn't have that if you mounted it rigidly. It's also really good if you're making hinges, especially for this game, if you're trying to model a hinge for like a tray mechanism. But regardless, we have bearing flats, we have axles, but we also have these sprockets and this wheel. This wheel is a tricky situation. We're just going to do the sprocket first, because all you need to do is select a central point here at the end of this flat plane. You want to make sure the flat part of this plane is highlighted. Select that, and you're going to want to select the flat part of the like the identical side on the axle. So to show what I mean here, we're going to go onto this plane on the axle, make sure the right flat plane is highlighted, and we're going to select a central point here. Oh, okay. Now obviously we don't want this to revolve, we want this to be rigid because we want the sprocket to move with the axle. That's another thing. Once you create a revolute joint, the majority of your joints are going to be rigid, so when you make a new joint, you're going to notice obviously if it's wrong, because it's going to do that calibration thing, and you're going to see, oh, well, that's not right. But you always want to switch it back to rigid. And okay, that's actually perfect. That's kind of where I want it to be. And of course, when you create a joint here, if it's not in the right spot, you can't just offset it on its particular axis, and it will only shift it on that axis. So if you move it on this axis, it won't like awkwardly move anywhere else. So we're just going to offset it by -4 millimeters and keep it there. And we have the sprocket. And the same deal would go for the wheel. The only reason I'm a little apprehensive to try with the wheel, you can do the same exact thing and get the same exact outcome. But in this case, since this doesn't have an insert inside of it, you'll have to offset it by a particular measurement so that it's centered onto the axle. And I'm not entirely sure what that exact measurement is at the moment, so I'm not gonna like spend my time doing that right now. But this is a great time to show here that since we've created a rigid joint from the sprocket to the axle, but the axle has a revolute joint on the bearing flat, we could do something pretty cool here. Whenever we spin the axle, the sprocket will spin with it, which is pretty nifty, and it allows for some creativity, and it's kind of cool to see when it works. The big problem is that it's time consuming. So I'm going to go here and I'm going to create another sprocket. And I'm going to show you the cheat way to do it. First of all, modeling bearing flats isn't really necessary all the time. I almost never model bearing flats on my robot because whenever I'm like making it in real life, I kind of already expect where the bearing flats are going to be. It's usually not necessary to model it if you're just trying to get idea, because the main reason behind CAD is to get a idea of your main structure, not to go through every minuscule detail, at least when it comes to, you know, thinking of designs and stuff. Maybe if you want to make a final version of what you made your entire robot already and you really want to meticulously just make a 3D model of it, then yeah, go and put all your bearing flats in and screws while you're at it. But if you're just experimenting with designs, doing what I just did here takes a lot of time, and you're going to be spending many more hours just making that design because you're doing, you know, time consuming stuff like this. So just usually don't bother with bearing flats, especially don't bother with screws. Screws are the biggest time waste that are completely pointless. But the cheat way to do this is extremely cheesy. But what you're going to want to do is you're going to want to select a face on this little cube that gives you an orientation like this. And you're going to want to physically move the wheel to where you want it to go. So say if you wanted your wheel to go here, for example, you're just going to just shimmy it on here. And it's helpful to just zoom in real close because you have the IMate dot here as a reference, the snap point. This snap point is at the exact center of the C channel hole, and this movement dot is at the exact center of the wheel. So you can just, you know, shift it right over here, just put it right on top of the snap point. This, of course, doesn't make anything rigid, but it does line up the wheel to where it needs to go. And then you can just shift on the Z-axis here, where the wheel needs to go. You could just put it right up to the Z-channel if you have to. And you can repeat the same thing with the sprocket. You know, you can go to go to the 18th 2 sprocket, go back to that face view, shimmy it into place, and then you can just slightly angle it onto here. Not angle it, but move it. I don't know why I said angle. Alright. And of course, yeah, I would move it onto the Z-axis as well. Let me just do that real quick. There you go. I don't know why it's not letting me move. There. Alright. And that's another thing to note. If you're zoomed out far away and you move something on any axis using one of these arrows, then it's going to have much larger increments of movement. So at this distance, it does it by 100s. But if you go super close up, it'll do it by increments of 1s or like 5s. I think maybe at like this distance, it'll go by 5s. So that's just something to keep in mind when you're doing something like this. But this is, again, the very cheese way to do it. There's nothing proper about this, and the only glaring flaw is so long as nothing, so long as you don't do something like this. So if you do the floaty method, so long as you don't do something like this where you just move the entire chassis, obviously if you move the entire chassis, it's not jointed to the chassis, and there's no way to joint it to chassis, so it's just going to stick there in free space and not move with the assembly. So that's just kind of a sacrifice you have to make for saving time, but you're never going to move the chassis in the first place like that, so it's kind of a, you know, a moot point. But basically, yeah, so this is a much quicker way to do it. One last thing I want to address is using standoffs and spacers, for example. The same way that we mounted the bearing flat, you can mount standoffs and spacers. Oh, I didn't put them here. Alright, we're going to have to go back. So if we go to hardware here, standoffs. If we spawn in a standoff here, we're just going to get into a view where we can angle it to 90 degrees. And if we create a joint, any object that has a circle on it, you can do the same thing we did to bearing flat. You can go here, you can find the circumcenter of the hole. When it comes to standoffs, it's a little bit tricky because see how there's like two planes here. You're going to want to pick the one that's the closest to the bottom so you get the most accurate measurements. And then you just want to click an imate joint, and it will shift itself into place. Again, to note, if you put it on any of the interior part of the C channel, it's going to be physically like inside of the C channel, because again, the imate holes favor as you can see in this view actually perfectly, they favor the flat side of the C channel. If you mount it to the flat side, then you don't have to do anything. But if you mount it to the inside, then you're going to have to offset it by negative 1.5 millimeters. And then it's perfectly aligned. And this same principle goes to spacers, which when it comes to general construction, the only three things you're going to use are, C channels, spacers, and standoffs. That's really all you're going to use when you're building. And washers have the same effect, where you can just select their circumcenter plane as a joint and joint them to the imate parts of the C channels. And that's basically it. Just to show you what you can do with Fusion, I'm going to do something maybe a little bit risky, but I'm going to go to my Fusion project, early season. These imates dots conceal a lot, so you're not going to really get too intricate with my designs here. If you really go on a microscope, maybe you'll see some leaks. Actually, I might just go into editing and just cover them up. But this was a prototype chassis that I made early season. There's a lot of components to it, so it's going to take a second to load, as you can see. Oh, and that's another thing I'll mention, actually, appearances. But basically, I floated all of these objects into place. Even the motors, I just floated them into place. And then I mounted these C channels that are points. And then you can create complex stuff like this. I mean, really, this isn't complex, but this is just an example of the kind of structures you can make these kind of chassis. But that brings me to an excellent point. If you are inclined to anodize your metal or spray paint your metal, you can actually change the appearances of all of the objects that you see here. And the way you do that is you go to modify and you go to appearances. So there's a few basic colors here. You go to paint, because this is really the one you're going to want to go for if when you're working on your robot. They have glossy paint, so if you're using a glossy paint on your robot, you can do that. I use more satin colors, so I usually stick to the powder coat because it's more representative. Powder coat smooth. And you can, say if you have a predominantly black robot, you can literally just drag and drop. You want to remove appearances to apply bodies, and you can repeat that multiple times over, and you can paint all of your C channels. And you can create custom colors too, and this is really quick, so I'm just going to mention this. If you go in this design, you can duplicate whatever colors you're using. So we're going to duplicate another powder coat black, and we're going to edit and rename it. First, before we do anything, we're going to name it powder coat teal. And you can select any color you want and create your own custom colors, any color in the RGB spectrum, and you can add that to your channels as well. So that's just a small, quick little fun thing to mention as well. But those are like the very fundamental, the very basic things you need to know to do basic construction using the I've included here, or that I included in the last video. I know that maybe my explanations were kind of rough because, as you can see, it's 3:15 a.m. I've been up since 6 a.m. and I was very tired at a soccer game earlier, so I might not be in the most energetic and explanatory of spirits, but hopefully my visual representations were able to convey what I was trying to get. And hopefully you understand roughly how to CAD. Because really, you can get the basics, but just experimenting and practicing and doing it a lot and exploring things on your own, like a lot of these methods were never taught to me. It was just things like, oh, I wonder how I can change appearances, and then I just discovered all this stuff on my own. And the same thing with, you know, creating joints from these holes. Like, I was never explicitly told that's what you can do, but you just got to experiment with it, just try different fun things, trial and error and stuff, and you'll end up learning a lot of new skills. Yeah, so it's a really worthwhile thing to do. It really is really good for prototyping designs and, you know, just brainstorming stuff before actually, you know, making it with metal. So I highly recommend that you guys take up CAD, that you know, maybe check back on this video every so often to make sure you're doing things right. I know my explanations are really bad, but you can just kind of compare what I'm doing here to what you're doing at home. And yeah, that's basically all I have to say. I'm going to include, probably throughout the next few weeks and into the future, mini tutorials on how to do different things like create working hinges in Fusion 360, because that's a thing that's not like really out there on how to do, and the hinges this year, like the hinge piece, might become a little bit popular. So I'll make a tutorial for that and different things. If you guys want a tutorial on how to do anything, I'll try my best to make anything, but just let me know. Again, if you go to the part library, if you download it, if you look at the README, there are 3 different ways to contact me. So that's me, Aiden from 712NE, signing off. Have fun catting.